Hello everyone, welcome back to the session of Material Science. Myself Rahul Mane and I am working as an assistant professor in the Department of Electrical Engineering, Kekewag Institute of Engineering Education and Research, Nasik. Today I will discuss unit number 3, that is insulating materials, properties and applications. So first of all, we have to identify the different insulating materials which are used in electrical equipment. Then we have to describe their properties, and finally we have to find out their applications in different electrical equipments. Learning outcomes. So at the end of this session, learner will be able to classify an insulating materials and to choose suitable insulating material for electrical equipments. Prerequisites for the sessions are breakdown strength, breakdown voltage, and dielectric loss. Already we have discussed these terms in unit number 1 and 2, but once again we will quickly revise that terms. So first, breakdown strength. The breakdown strength is defined as minimum stress usually expressed in kV per mm. Keep in mind, minimum stress usually expressed in kV per mm, which will cause the rupture of insulating material under specified conditions of temperature, duration of applied voltage, waveform of applied voltage, frequency, and type of electrodes. Okay, so this is the in short definition of breakdown strength, and its formula is breakdown strength is equal to breakdown voltage divided by thickness of the dielectric, means kV per mm. Okay, so this is the breakdown strength. Next term, breakdown voltage. The voltage below which dielectric materials remains stable in the property, but above which it results in destruction of insulating properties, is called as a breakdown voltage. In short, the voltage above which insulating material will loses its property is nothing but breakdown voltage, and it is expressed in kV. Third term, that is dielectric loss. Now what is dielectric loss? Conversion of electrical energy into heat energy whenever an dielectric material is subjected to an AC supply is nothing but a dielectric loss, and which is given with the help of formula P is equal to 2 pi fc v square into tan delta, and already we have derived the expression of dielectric loss in unit number 1. Okay, now with the help of these parameters we will describe the properties of an insulating or good insulating materials. Okay, so let's introduce the insulating materials. So basically we know the difference between dielectric and insulating materials. Okay, so function of a dielectric material is to store a charge, whereas insulating materials are used to oppose the current or oppose the flow of current. Okay, so from this I can say all dielectric materials are insulating materials, right? But all insulating materials are not dielectrics. Okay, so this is the basic difference between dielectric and insulating material. Now, here I have summarized some few points regarding the insulating materials in short, but we will discuss one by one point. So, first point is nothing but classification of insulating material. Now, if I want to classify the insulating material, then I can classify the insulating material depending on their capacity to allow or oppose the flow of current. Okay, means some it may happen that some materials will allow the flow of current, whereas some material will oppose the or strongly oppose the flow of current. Okay, so based on that I can classify the insulating materials. Okay, now second points, offers very high resistance. So already we know that if we are talking about the insulating material, then the basic function of insulating material is to offer a very high resistance. So I can say insulating materials are those which offers very high resistance to flow of electric current through them when subjected to an electric potential. Okay, so this is the second point regarding the insulating material. Now next, role of insulating material in electrical equipments. So we know that everywhere you can observe electrical as well as electronic equipment. everywhere. In order to protect these equipments from each other, we need a insulating material. Okay, so that is the important role of insulating material, to provide a safety as well as to protect an equipment from different potential level. Okay, or from the leakage current or fault current. Okay, so this is the main role of an insulating material in electrical as well as electronic equipment. So what will be the properties of good insulating materials? Okay, so you can talk in different terms, or you can explain the different properties of a good insulating material. So some property I will say here: an ideal or good insulating material will should have high insulation resistance or insulating resistance. Again, it should have high mechanical strength. Okay, or I can say it should have less dissipation factor, or good dielectric strength, high thermal conductivity. Okay, so these are the some properties of an good insulating materials. Besides these properties, it should be easily available, easy to fabricate, and cheaper in cost. Okay, again, these are the some properties of an good insulating materials. Okay, now we will move towards the next point, that is types of insulating material used in electrical equipment. Now consider or imagine all electrical equipments. Okay, so you can imagine any equipment. So let's imagine a transformer. If I'm classifying, or if I'm separating the insulating materials used inside a transformer, then I will obtain some insulating materials are in solid state, some of them are in liquid state, whereas some of them are in gaseous states. Okay, so likewise we will have different types of insulating materials. Okay, so here I have enlisted some solid, liquid as well as gaseous insulating materials. If we are talking about the solid insulating material, then we are having paper, rubber, cloths, etc. If we are talking about the liquid insulating material, then I am having mineral oil or transformer oil. Again, I can have synthetic fiber, synthetics, or I am having hydrocarbons. Okay, so these are the some examples of liquid insulating material. Again, if you're talking about the gaseous insulating material, then I'm having air, nitrogen, SF6 gas, which are used in industry for an insulation purpose. Okay, so this is the short introduction to an insulating materials. Next, properties of good insulating material. Okay, so if I am talking about the properties of good insulating material, then first of all, I need to consider the electrical properties of an insulating material. Okay, then I can talk regarding the chemical properties. Okay, again, I need to consider the thermal properties, that is temperature capacity of that insulating material. And again, I need to consider the mechanical properties of that insulating material. Okay, so if all these properties, that is electrical, chemical, thermal, mechanical properties are good, then I can say that these insulating materials are good in nature, or good insulating materials. Okay, so we will discuss one by one properties. Okay, so first of all, I will discuss the electrical property of an good insulating materials. Okay, so first property of an good insulating material is high insulation resistance. Now what is insulation resistance? The insulation resistance is nothing but opposition to flow of leakage current, is nothing but an insulation resistance of that insulating material, and it should be high in nature. Okay, so we know that insulation is provided over the cable or any other electrical equipment. So I will comment something regarding the insulation resistance. So what is insulation resistance? It is opposition to flow of leakage current, and we know that in case of cable, if I'm considering a particular cable, then insulation resistance decreases with increase in temperature. Okay, so if temperature is increasing, then obviously that material or insulating material will lose its insulating properties somehow, not all, but somehow it will lose its insulating property, and insulation resistance will get reduced. Okay, means temperature is affecting on the insulation resistance. Again, with the due to moistures, again there is a reduction in insulation resistance. We know that if there is a presence of moistures content, then such moistures content help in transferring the charge, and hence the insulation resistance will get reduced. Again, we know that in case of cable, insulation resistance is inversely proportional to length. As there is increase in length, insulation resistance may go on decreasing. Okay, so it is inversely proportional to the length of that cable. Okay, so this is the first property of an good insulating material when I am talking about the electrical properties of an insulating material. Okay, so the insulation resistance should be high. Okay, now next, low dielectric loss. Okay, so we know that conversion of electrical energy into heat energy is known as a dielectric loss inside a dielectric material, and that should be low in case of a good insulating material. Next, high value of dielectric strength. Okay, so obviously, any insulating material should have high value of dielectric strength so that it withstand higher voltage without breakdown. If an insulating material is having high dielectric strength, then it will withstand higher voltage. Okay, and it will not get break, or it will not get breakdown in such higher voltage conditions. Okay, so this is the another property, that is another electrical property of an good insulating material. Next, it should have low permittivity. Obviously, if permittivity is high, then it will allow some charge to flow through it. Okay, so in order to oppose the flow of charge, it should have low value of permittivity. Next, low power factor. So what is power factor? It is a measure of power loss and it should be low. Okay. And this power factor increases with rise in temperature. Our power factor and dielectric constant at power frequency can be used to compare insulating material and determine the effect of environment and operating conditions. Okay. So that's why the power factor should be low. It means that power loss will be low. Okay, so these are the some electrical properties of an good insulating materials. Now let's move towards the another section of an good insulating property is nothing but chemical properties. Okay, so along with the electrical property, that material should also have an good chemical properties. Okay, so in chemical property, that material should be resistant to oil, gas fumes, acids, and alkalis. Okay, so that material should repel or resistance. Okay, or so there should not be any effect of oil or gas fumes, acids, alkalis on the insulating materials. In short, I can say that that material should be chemically stable. Okay, or it should not react with the acids or alkalis. Okay, so this is the first chemical property of a good insulating material. Next, non-hygroscopic. Okay, so that material or that insulating material should be non-hygroscopic in nature. So what is non-hygroscopic or hygroscopic, or what do you mean by hygroscopic? So hygroscopic means should not absorb water. Now we will discuss the purpose of impregnation process. Okay, so the fibrous insulating materials have air pockets or gaps inside them, and they are present during the manufacturing process. Okay, so at the time of manufacturing of insulating material, and it reduces permeability and dielectric strength of the insulating material. The breakdown occurs in these air pockets, making insulation worse. Okay, so as there is a presence of voids, gaps in the insulating material, and which leads the breakdown of an insulating material at a worst conditions. Due to this, electric field also become non-uniform in that material. Okay, so whenever you are using such fibrous insulating material, and if there is a presence of electric field, then it will get non-uniformly distributed over the surface of that insulating material, and which leads breakdown of that insulating material. So by the process of impregnations, air pockets are filled with the varnishes and making them electrically strong and producing uniform electric field intensity in the material. Okay, so if I am doing the impregnation process, all the voids or gaps present on that paper will get covered, and the mechanical strength as well as electrical capacity of that insulating material or fibrous insulating material will get improved. Okay, so these are some advantages of impregnation. So conclusion, so here in this session we have studied the classification of insulating material and applications of such insulating material in the electric devices or equipments. Thank you.